CAM software. Thanks for joining us. We're just going to wait a couple more minutes for other people to join. So in the meantime, I'd like to start off with a poll just to cover, just to discuss or just to give us feedback on what you want to see within the demonstration. So just hold on for 1 second. Made in terms of the answers, and it looks like we've got some people that are familiar with Autodesk Inventor, Fusion 360, SketchUp, and also looks like predominantly everyone wants to learn 3D modeling and CAM, and a little bit about 3D printing. So we can discuss those topics. And I also want to introduce you to Wayne Griffenberg. He's going to be running majority of the demonstration. Throughout this whole presentation, we definitely want you guys to ask questions, so you guys can use the Q&A or also the chat that's under the More section of the Zoom software. So to get started here, I just want to give a high-level overview of Fusion 360 to answer some questions, and then we'll move into the live demonstration. So you know, Fusion 360 is been in development for 7 years, but it's been built from the ground up to leverage cloud computing and cloud storage, and also other technologies in terms of mobile devices and multi-threaded computer processing. And Autodesk saw a need to build that software because a lot of our software packages were built in the mid-90s when a lot of these technologies were not available. So we had to build a next generation platform. One of the great things that Fusion 360 offers is one tool set that's fully integrated. So you can go from concept to fabrication in one interface, which allows you to only have to learn one interface, maintain one interface. And so all the issues with compatibility are not a problem. And then you also have the associativity benefit. So a change made is a change made everywhere. So renderings, CNC toolpaths, FEA analysis will all update with changes to a model. Another component of Fusion 360 is that it is cloud-based, and so it allows you to stay connected and collaborate with others very easily. And you also have access to your data at all times because there's cloud storage built in. So it allows you to stay in real time with your data, whether if you're using it at home or at the office. You don't have to worry about where my files are stored. Some great aspects of the file storage is that there's automatic versioning, and your login is what also allows you to audit your changes. So working with others, you can see make changes to which files. And then you also have a 0.5 terabyte of storage. So it's virtually unlimited, and it really allows you to start not only Fusion 360 files, but other Microsoft Office documents, PDFs, anything you would want to associate with a project. And so what I want to cover here is just a quick video, quick overview on Fusion 360, and then we'll move on to the demonstration here.
What is Fusion 360? Is it a cloud-enabled collaboration platform that enables designers to instantly share, review project data, manage versions, find, aware, use, and Share ideas on any device at any time? Is it a 3D CAD application with both freeform and solid modeling tools seamlessly integrated?
Oh. Sorry about that, guys.
What is Fusion 360? Anytime? With both freeform and solid modeling tools seamlessly integrated into one application? Is it a 3D animation and rendering application? Is it the first cloud-enabled tool to provide 2D drawing capabilities? Is it simulation software? Or is it a CAM application for turning and milling operations? This is what you need to know about Fusion 360. It's not any one of those things. It's all of those things. It's the next generation product innovation platform designed to work on Mac, PC, and mobile devices. So come on, what are you waiting for? Try Fusion 360 today.
All right, great. Well, thanks for sitting through that quick overview, and now I'm going to pass it over to Wayne to show you the live demonstration.
Awesome. Thank you, Charlie. Let me bring up my screen real quick. Awesome. So it looks like the results of the polls we're in. It looks like the majority would like to see some sketching in Fusion 360, some 3D modeling, and CAM. So we can definitely cover those topics today. And so, as Charlie had mentioned, if any of you have any questions, please feel free to use the Q&A section to ask your questions, and I'll do my best to answer them. And if we don't have an answer, we'll get one for you. So I'm going to go right into my Fusion 360. Before I do, I'm going to work through a part. One of the parts I used to make back in the shop, we had in our tool and model shop. We had a bunch of motorhead guys, and I was one of them. And we used to work on our cars and swap out different components like carburetors, right? So we'd put like take a Holly carburetor off the 350 Chevy, and then we'd put on like a Holly 4-barrel or Holly double pumper on an Edelbrock interface. So what I'd like to do is I'm going to start to draw up that adapter plate. So I'm going to draw this simple adapter plate, a part that a lot of people have likely made very similar parts, very prismatic, and a part that is pretty easy to draw up. And we're going to go through that process, how to sketch it, how we would make a 3D model from it, and how we would machine it in the machining interface. So I'm going to draw a part similar to that. So let's go into our interface for Fusion 360. So this is our design workspace. These are different workspaces that are part of Fusion 360. They're all part of your subscription, so you don't have to download anything special to do rendering or generative design or work with animations, simulation, manufacturing, and of course doing all your drawings from your designs. And I'm going to work in the design space. We're going to spend some time between there and manufacturer workspace. This is our interface for design. We work with a few different engines that run simultaneously as you're working in to create your designs or importing your designs. So we have a full parametric design workspace where we can do extrudes from our sketches or revolves and sweeps and those features that you're used to with parametric design in CAD, as well as work with primitives and other components of parametric design, as well as doing direct modification. So if you import a step model or an IGES file that doesn't have a history, you can easily remove holes, change the size of holes, delete chamfers, delete fillets, and replace them, scale or combine your bodies. So we do have a direct modeling engine that works inside of Fusion as well. And the third main engine that we do work with is Sub-Divisional Modeling. We have a technology that Autodesk has developed called T-splines, which enables you to take a model, which would be like a sphere or a simple cube, and be able to press and pull and stretch it and turn it into something like a handle that you could 3D print or machine later on. And we also work with surface modeling. We have some tools to do direct surface modeling, as well as sheet metal, a very easy to use and robust tool to make your sheet metal parts. There's no difference between the assembly environment and the design of the part environment. It's essentially one document that you can control all of those different aspects of your design. So let's start off with our sketching. So I'm going to make that solid model we looked at, that adapter plate. So I'm going to start sketching in our design interface. This is called our canvas view. This is our browser where we can expand down at any time and change our units from inches to millimeters or centimeters, where we can look at specific views. We can zoom into the model. And I'm going to expand down this origin where we could see the X, Y, Z planes or axes, as well as the different planes that we're going to work on in 3D space. In the upper right corner is our view cube that you can grab a hold of at any time. And you can see the X, Y, Z axes along that view cube. And also in the lower left, we have our timeline. So as we move back and forth in time, as we start to create sketches and features and bodies, you'll start to see them added in the timeline here in the lower left corner. So let's start our design. So I'm going to work on the XY plane. I can select it right here in the graphics view. I can also select it from the pull down from the browser here. So if I right click on that feature, I like to use the right click menu. It's just quick and easy to be able to get to those different features that make sense on what you right click. We call it the masking menu. You can also use the browser up here to create a sketch as well as other functions that you need to pull down to. But I'm going to right click and go down to create sketch, and it brings me into the sketch mode. So I selected a plane and I chose to create a sketch on that plane. So now we're looking at that XY plane. I can see the Y axis, the red X axis, the green Y axis, and the blue Z axis is coming out towards us. And notice on my browser, we now have a sketches folder. So it created a sketches folder with the sketch we're working on right now, as well as my timeline now has a sketch that we're working on. So in the sketch mode, I also have a sketch palette that popped up that gives us some additional options as we're sketching in this interface. Our ribbon bar has changed over, and now we have the sketch tab in which we're working on this sketch that we're doing right now. We can create lines and rectangles and circles and arcs and splines and so forth. We can also modify those different features to add fillets and trim and extend and break. And then we have our constraints. Our constraints are there to help us with our design intent. If we want lines to be parallel with each other or perpendicular, we can add constraints. And Fusion often looks at our design intent as we're designing and adds those constraints automatically, as we'll see. So I'm going to zoom out with my middle mouse button, which will now change the number line. So I have a good idea of how big the part's going to be as we're working through. I'm also going to put a rectangle in this quadrant down here. So I'm going to work in the fourth quadrant by placing a rectangle there. So I'm going to go up to create. I can see it here also on my ribbon bar, but I'm going to choose rectangle. I'm going to make a 2-point rectangle, and I can also hit the R key. So we do have some quick keys that you can use to get to those functions, like a C for circle, right? L for line. So I'm going to choose 2-point rectangle. And now attached to my cursor, that rectangle icon, as well as my sketch palette now has some options we can turn on and off for those particular rectangles. So what I'd like to do is I'm going to attach this upper left corner of my quadrant. I'm going to snap to that origin and start to drag down to the right. Now notice as I start to drag, it almost rubber bands these dimensions of my rectangle. So I can plug in the Y and the X dimensions. So this is actually going to be a 5x6 rectangle. It's going to be 5 on the Y and 6 on the X. So I'm going to type in 5 on my keyboard, hit the tab key, locks it in. So now I'm locked in on the Y dimension. I'll do the same thing on the X dimension. I'm going to type in 6, hit the tab key, it locks it in. So now I have a 6x5 rectangle. The only options I have are which quadrant makes sense for that solution, right? So I'm going to do it in this fourth quadrant down here. I'm just going to click in this area of the canvas view, and now I have this region to work with. Notice I still have the rectangle command attached to my cursor. I'm going to hit the escape key to get out of that command. So we have a 6x5 rectangle. And what we mean by parametric design means we can always go back and make changes to our sketch, our body, or our features. So if I did want to go back and make this, let's say, a 5x7 rectangle, I could just double click the dimension, type in 7, hit enter, and now we actually changed the dimension of the model. I want to keep it 5 by 6, so I'm going to change that back to 6. And so we're able to change our design at any time by changing the dimensions of the sketch. Also notice that we have these constraints, right? Fusion, as I'm drawing on the XY plane, recognize that we have some constraints of lines that should be vertical, or shall I say horizontal in this case, and vertical here. So it added the vertical and horizontal constraints. Let's say I didn't really want this constraint to make this vertical. Maybe I want to put an angle down here. I could select that constraint and delete it, and now I can start to stretch that angle. If I want to add a dimension for that angle, I could just simply go up here and sketch dimension. Another way you could do that too is just hitting the D key. Notice that D, when I hover over the D key next to it, simply will bring up a dimension. And I can add a dimension between these edges right here. So if I select this edge and this edge, I can add 60 degrees or 50 degrees, whatever I like. In this case, I am making a rectangle that represents the base part for that adapter plate. So I want to put that vertical constraint back in. So I'm going to choose my constraints. I'm going to snap it on there, and it puts that vertical constraint right back into my model. So that's just a quick overview of how constraints work. And in the sketch mode, I'm able to make a rectangle. I was able to dimension it and add and change the constraints that drive the rectangle. So now what I'd like to do is just show you how we can turn that really quickly into a 3D model. So I'm going to change my view. I'm actually working with a 3D mouse that makes it easier for me to rotate this around. But you can also use your Shift key with your middle mouse button. At the same time will bring you into orbit mode. So Shift middle mouse will let you orbit the part around to be able to change the view that you're looking for. Also, you can also grab a hold of the view cube to be able to move your view around as well. Right, so I'm going to get this almost in an isometric view, but I'm going to actually create a solid from that sketch. So I'm going to choose the solid tab, and right here I have extrude. So I'm going to choose extrude, and it switches into the extrude mode here, this extrude function. If I select my profile, which is basically the region that I created, I can now use that region to be able to pull a 3D model up or a 3D model down. So we're actually just making a brand new body from that sketch boundary that we created from sketch. Notice as I pull it up and down, it's changing the dimension. I'm going to make this a -1/2 inch. And so I'm going to have a 1/2 inch thick plate to work with. Also notice that we can also change if we want our direction to be up or down, or even if we want symmetric, we can add symmetry to the body itself by putting a 1/2 inch above and a 1/2 inch below the sketch plane. In this case, I'm going to keep it one side, and we're going to make a new body. As I had mentioned earlier, if my intent is to make an assembly, and if I want to maybe make a gasket under that adapter plate, I can start to change this. For instead of making a new body, I can make a new component. The difference being that in my browser, where I have this sketch and a body, it would then take the sketch and body and place it into a new part that has its own origin and its own body. So therefore, a new component will be like a part in an assembly. In this case, I only want to make a new body because I'm not going to add any features, or I'm not going to add a gasket. I'm going to keep this as just new body, which then will keep the part, the body, and the sketch in the same part environment. I'm going to say OK, and now we have our body. So we had our 3D sketch. Notice also on our browser, we don't only have our sketch, but we also now have a body folder. And on our timeline, we have the sketch, and we have the body that was created from the sketch. And if I roll this timeline back, before we had the body, notice it doesn't even show the bodies folder in the browser. So it's like we're going back in time as if we only had the sketch at this time. So we can make design changes and then roll those design changes forward in time to match our model. So that's how the timeline works. And now we're ready to start adding features to our body. So I'm going to add a new sketch on the top face of this plate. And so I'm going to make it this shape like this. I want to make this a profile I have the upper left quadrant. If you look at the part, it's symmetric itself, right? It's got symmetry around the vertical, symmetry around the horizontal. So I can work in one quadrant of the part and then mirror those features. So let's work here and do that. So I'm going to create a sketch on that same plane we did before, create a sketch, and I'm back into the sketch mode, but notice we now have a new sketch because I created a new sketch on the same plane. Our old sketch remains, it's just I happen to be working on that new sketch at the moment. So I'm going to hide this body. So the body is sort of getting in the way. If I start to draw, I might highlight it. I could just simply hit the little light to hide it. So now we're ready to start drawing. What I'd like to do is I'm going to use the dimensions, the 6x5 dimensions from our previous sketch. I want to project them or copy them into the new sketch. So I'm going to turn on that sketch so I can see those features, and I'm going to project those lines into this sketch. So if those dimensions, the 6x5, happen to change in the future, so will my new sketch features because they're derived from those lines. So I'm going to go to Create, Project Include, Project, or you can hit the P key, and I want to project these lines into my new sketch. So after I projected those, I'm going to say OK. And now if I hide the old sketch, I can see the newly projected lines in my new sketch. Okay, so now I want to add that symmetry, right? So I want to work in this quadrant of my part, and I'm going to mirror about the horizontal and then mirror those features about the vertical. So I want to bisect my model about horizontal and vertically. So I'm going to choose a line, and another way to get to tools, I'm going to give you another tip and trick. Instead of using the ribbon bar, which can take a little while to go up here and pull down and find your different features, you can right click in any negative space in the canvas view, and if I pull my mouse down, right? So if I right click and hold it and I drag it down over top of the sketch menu, it'll then open up to these different features that we can use by just simply by gesturing to those directions. Like if I pulled down and I went to 10 o'clock, I can get a circle. If I went to 2 o'clock, I get a rectangle. If I move to 6 o'clock, I get a line or an offset or a project. And at 9 o'clock, I get a dimension. So I'm going to do that. I'm going to hit my escape key. I'm going to gesture to be able to get the line. So I'm going to gesture down, and then I have a line. So I just held in my right click, gestured down twice, and it gives me a line command. We'll do that again. If I want to get a dimension, I just gesture down, 9 o'clock, I get a dimension. So it takes a little bit of practice, but when you get to know where those different features are, like rectangles and circles and lines, this will turn out to be a much quicker way for you to work with Fusion in the interface. So let's use a line. And now I'm going to bisect this model. And if I hover over and if I snap, I can snap to the midpoint. That triangle is basically a midpoint snap. So if you ever work with AutoCAD, Inventor, or other CAD interfaces, you'll see very similar snap tools with similar icons that make sense. So I'm going to snap from the midpoint here. And as I start to stretch this line, notice I get a dimension and a angle. So it's basically a vector line. And if you do this, if you hover over and see how it snaps to the horizontal, it automatically gave me that right angle snap right there, right? So it recognizes the fact that I probably want those lines to be perpendicular with each other. So it gives me a preview that it's going to snap to the right angle. And I can also plug in a dimension, but I want this to be from midpoint to midpoint. So I'm going to snap from the midpoints. I'll do the same thing in the horizontal. And now I snap to those midpoints. But since there's solid lines, it now bisected my sketch where I can use any of these 4 quadrants and extrude them as solids. I don't really want them extrudable. I don't really want them to be bisected that way. I want these to be construction lines. So I can simply select the line and go up here and choose construction off of our sketch palette. You can also use the X key on your keyboard. So now we have these as construction lines that can continue designing in this quadrant of the part. So again, I'm going to use a line. So I'm going to gesture down, then down. I get a line. And now I'm going to snap to this vertical line in the center. I get that intersection snap that pops up. And as I start to draw, the same vector, the same right angle snap. And as I start to draw, I'm not worried about dimensions at this point. I just want to be able to get the basic shape. So I'm going to click there and I'm going to continue to design. Notice that once we finalize that line, it automatically gave us the constraint for perpendicularity automatically because these lines are perpendicular. I'm going to continue, and if I hit the green check, it means I'm going to stop the line command, but I'm going to continue drawing it around. And notice as I keep that same right angle snap, it gives me the perpendicularity constraints. So as we go through our design, these lines are always going to remain perpendicular to each other. Right, so that's Fusion trying to help us out by putting the constraints on the model for us. Basically, I'm looking at that shape I'm looking for. I'm going to add some dimensions in a little bit, but I want to add a few more constraints. And in fact, I want to add some fillets around these corners. So I'm going to choose fillet. I'm going to select that corner, and notice it gives me a highlight that it recognizes those corners as fillet, that I can put a fillet on there. So when I select it, I can drag the size of the fillet that I'd like. I'm going to make that 1/8 of an inch. And before I change, I'm not going to hit enter or hit any other key. I'm just going to work my way around to these other corners that I want to have an 1/8 inch fillet onto. So as I add those fillets, notice we also now have these constraints for tangency. I'm going to hit enter to stop the command. And now we have fillets and we have the tangent constraints added for us. Okay, so the next thing I'm going to do is I want to add the dimensions to lock down our design. So I'm going to go up and use dimension, or I can right click 9 o'clock and I can start to add the dimensions. This will be a 1/2 inch. This will be 1/8 of an inch. So I'm basically adding the dimensions from my datum lines, right? And these are really coming from, our initial sketch that has the overall box, right? So I'm going to add a dimension between here. This will be a 1/2 inch. And so now I'm going to add the dimension for the width of our part there. So I'm going to say 1 inch and 3/4. And now notice that this is still blue, which means I can move it around. It's not fully constrained, right? So now I can actually stretch this and make it bigger. So I'm going to add a dimension between here and here, and we're going to make that 1 inch. Okay, so now we're fully constrained. All the lines are now black. There's no blue lines that I can stretch around. So now what I'd like to do is I'm going to add a couple more features, like a slot in here that represents the area where the two holes are going to meet, like a slot feature in there. And then what I'm going to do is I'm going to add the central venturi, and we're going to add that to our 3D model. So let me add the slot feature real quick. So another way is I can go up here to create. I can go down to slot, and I can add that center slot that I'm looking for. Just to show you another way we can get to those features, if you hit the S key on your keyboard, brings up sketch shortcuts. Now, when you first start, this is usually empty, and you can simply search for your different features that you're looking for. And then you could choose, overall slot or center point arc slot. And these I happen to already add, and there's an arrow that pops up here that you can add those features right to your sketch shortcut. So in this case, if I want to add a slot, I could just simply choose slot, and now I can start to draw a slot in here. So this is going to be a 3/8 slot. So I'm going to add the 3/8 diameter. And now it's basically ready for me to dimension because I didn't add any dimensions, kind of floating in space. So let's dimension the overall width. We're going to make this 3/4. And we're going to add a dimension from this edge to the center, and that's going to be a 1/2 inch. And now what I'd like to do is I want to add a dimension that I can select, and I'm going to check this with a caliper later, but I want to grab that tangent edge right there. But right now it just wants to grab the center. If I right click over that arc and I choose pick circle arc tangent, now I can select the tangent of that arc to make it a 1/4 inch. So now we're locked down. Or not, again, our design is now constrained. And so what I want to do now is I want to bring these features from this quadrant, mirror them into this quadrant down here. So I'm going to go and use the mirror command. So up under create, I can go down to mirror. And again, I could use my shortcut too. So I'm going to choose the objects. Now notice I want to put a box around this area, but it's kind of filled up with my constraints. And I don't want to grab a constraint by accident. I could just turn them off by choosing and disabling show constraints. So now I think it's stop my mirror command, so I can just start my mirror command. And I'm going to start a box right around that geometry. And creating a box going from left to right will select whatever's inside the box. Creating a box going from right to left will select anything the box touches, right? So I don't really want that line, but I do want this geometry. So I'm going to choose my mirror line. I'm going to mirror about the horizontal edge or horizontal line. And now I get a preview, and now I have mirrored those features. Let's do the same thing again. I'm going to right click and drag up to repeat the last command. And I'm going to put a box around all those sketch features, and I'm going to mirror them about this central vertical line. So now we have our different regions now that we can work with. Okay. The last thing I'm going to do is I'm going to put the Venturi in the center. So I'm going to go and add a rectangle, a 2-point rectangle. And again, I can always gesture, down, up, and to the right about 2 o'clock, and I get a rectangle. So I'm going to add the rectangle in here. This is going to be a 2.5 on the Y by 3 on the X. And now I have that region, that rectangular region that we're going to work with. Now, it's kind of floating in the middle of the model. I actually want this to be quite symmetric about the center of the part. Again, I can choose my dimensions from, let's say, this edge to here, and then I can kind of build up some tolerance stack up there if I didn't want to. But my design intent is really to have this to be symmetric in the center of this model. So I'm going to choose symmetry as a constraint. Symmetry, I want this edge and this edge to be symmetric about the central horizontal line. And I want this edge and this edge to be symmetric about the vertical. And now we just added symmetry about the center of the model. Okay, so now let's continue and let's add these new sketch features into our design of our model, of our 3D model. So I'm going to switch back over to our solid modeling, and I'm going to choose extrude. And again, it goes back into that first step of extruding the model. I'm going to turn our body back on, and I'm going to choose this region that I want as a profile that I want to extrude. Notice if we start to extrude it up, it wants to join that body. It wants to join the new body from the new sketch to my original body. If I start to pull it down through the model, it switches over to become a cut. So Fusion recognized that I'm going down through the model, that I want to cut through the model. So, and that's what I'm looking to do. I'm just going to pull it down. I'm going to say OK. And now we've cut through that body, that basic shape from our sketch. I want to continue that same process to make the slots in the central Venturi. So I'm going to turn on our sketch, and I'm going to do the same thing. This time I'm going to choose Press Pull. I like using Press Pull in the Modify menu because it's like the Swiss Army knife, right? It's a multi-tool. So if I select that Press Pull and I start to select these regions for the slots, I can pull them down. It did become an extrude, and I can extrude them down into the model. I'm actually going to extrude them down 1/8 of an inch. And now I have those slots 1/8 of an inch deep. I'll do the same thing with the central Venturi, right? So I'm going to go up and do my press pull, grab that region, start to pull it down, it becomes an extrude. Now I do want this to go exactly 1/2 inch because I want this to be tapered. I want it to be a -25 degrees, so we actually get a tapered or lofted cut through the model. All right, we're going to say OK, and now we have a tapered cut. And I actually do want to put some fillets in here, but I'm going to do that in a couple seconds. But I want that to be a constant radius fillet going all the way through that edge. The last thing I'm going to do is I want to add the holes. Well, the next thing is add the holes in the center of each of these slots. Now, in traditional CAD, we'd have to go into create circles on a sketch and be able to extrude those circles through. What I'm going to do is I'm going to use the hole command in Fusion to create those holes. I can choose a tapped hole. I can do counterbore, countersink, or countersunk hole. I'm actually just going to start to select the center points of those slots. I'm going to give it a diameter of 1/4 inch, and I want those to go all the way through our model. So now we have a 1/4 inch hole at the center of each of these arc center of the slots. So I just simply select each one of those points, and now we have holes in the model. Okay, so I'm going to hide that sketch, and the last thing I want to do now is I want to get these the radii right in the center of these arcs here, or these lines here. So I'm going to choose Press Pull. Now remember, Press Pull depends on what I select. So if I select this top face, it becomes offset face of the model. That's not really what I want to do. I'm going to use press pull. I'm going to select this edge and it turns into a fillet. I'm going to select the additional edges and it selects right through the model. I'm going to select them and I'm going to start to drag a fillet, a constant radial fillet in those corners. I want that fillet to be a half inch, and now I have a half-inch constant fillet in those corners of the venturi. Okay, so I'm going to save our model here. Looks like we're ready to start to machine this on our machine. So I'm going to hide my origin for now so I can show you how to set up the origin in CAM. But just keep that in mind that the origin that you design does not necessarily have to be the origin of the way you set it up in the machine. So let's hide that for now. And I'm going to save the model here in a project. Let me open up my project. I happen to be working in my Fusion 360 webinars project folder. So in that project, I'm going to save this adapter plate. So I'm going to go to save. It's going to save in that project. Let's go and call it adapter plate. So as I'm saving this, Charlie, I don't know if we got any questions that came in, but this would be a good time to answer some of those questions.
So we have one question that I was addressing just by typing, but it has to do with using RS Inventor and Fusion 360, and if you would prefer to model in Inventor or model in Fusion 360, and then use Fusion 360 for the CAM functionality.
So we do, if you do model in Inventor, just to let you know, we do have in our product design and manufacturing collection, the CAM interface, which is HSM. So it's Inventor HSM or Inventor CAM that you'll have access to in the collection. And that would add would actually integrate directly inside of Inventor that you can design your parts there and then put the CAM toolpath. Exactly the same CAM that you find inside of Fusion is inside of HSM or Inventor HSM. So that may be a potential solution, but you can design your part inside of Inventor. We use AnyCAD where you can bring that part into Fusion 360, and you can use the CAM inside of Fusion 360 directly on top of that part. There are a number of parts that you can upload and import inside of Fusion. So if you select those files, just to give you an idea, you can select all of these different types of files that you can bring into Fusion 360, and you can also bring in, of course, Inventor files as well. But you can import CATIA, DXF, IGES files, NX files, Object, Parasolids, Pro-E, or Creo tools, Rhino files, SolidWorks, Solid Edge, step files, STL files, and you can bring these files directly into Fusion. They will translate on the cloud for you, and you'll be able to work with those files. Now, bringing an Inventor file into Fusion, it is possible to be able to bring the file. It does connect to the original Inventor file, so that if the original Inventor file updates, you can have it update inside of Fusion 360. So you can import those files if you want to use Fusion for CAM. It is quite possible. So hopefully that helped to answer your question. And so I think we're going to get into the CAM side. So I'm going to close out of my data panel, and I'm going to switch over from the design workspace, and we're going to go down into our manufacturer workspace. So in the manufacturer workspace, we switch our ribbon bar, or our browser, and our ribbon bar is now changed over to those features and functions that we need to be able to put toolpaths on our models. So we have 2D toolpaths, which are driven by the edges or the lines, splines, arcs, and sometimes points of your model or sketch. 3D toolpaths are driven by the surfaces, faces, and edges of the model itself. And we have our drilling toolpaths, which are universal. We do have some simultaneous multi-axis toolpaths like swarf, multi-axis contour, and flow, where swarf uses the side of the tool and keeps it constant normal to a surface or edges. Multi-axis contour always keeps the tip of the tool normal to the surface that you're cutting and follows the geometry that you choose as your path. Flow toolpath is a 3-axis, 4-axis, or 5-axis solution, which keeps the tool normal the tool tip normal or the side of the ball of a tool normal to the U and V surfaces of your model. We do have turning toolpaths, so you can run your lathes directly from the same interface. It's exactly the same workflow as you're working and turning than it would be for 2D or 3D toolpaths or drilling. We can also set up toolpaths that'll run your water jet, your laser, or plasma cutter. Okay, so let's go in. The first step we do, working from left to right, is we would set up our model the way it matches our machine. Right, so we have this powerful 3D CAD environment and CAD CAM environment. We might as well use that to mimic and closely describe exactly what we're trying to do and what we're trying to get off the machine. And so also notice our browser changed over, where we can even change different units for CAM than we would have for CAD. And also we can get to our model, and any features or bodies or sketches that we'd like to get to, we can get to right here. And so let's start with our setup. So working from left to right, the first thing we do is select setup to set up the part the way we have it in the machine. So it recognizes the boundary of the part, and it gives us the minimum size stock we would need to cut this part out. It also gave us our origin in the top center and our X, Y, and Z orientation. So if I didn't want to have the top center, maybe I'm not going to probe this part, perhaps I want the upper left corner to be my 0, the upper left corner of the stock. I can easily go into box point, and now I could choose any edge or our corner that I want to have as my 0, my datum or G54. Now, the way this was brought in, and I actually designed it in a way where I have my X, Y, and Z axes normal to the top of the part. But let's say perhaps I didn't really want to have that orientation. Let's say the part comes in like this. Maybe it was designed like this with the Z in this direction. And perhaps I want to come in and fly cut this pocket. Right, so I want to go back and forth and cut it that way. But my Z's in the wrong direction. All I have to do is select the shaft of the Z, select that face, it flips around and becomes normal to that face I selected. Let's say we want it this way. Again, the same exact process. Select the shaft of the Z, select the face you want to be normal to, and the upper left corner is where it selects. So it's really quick and easy to be able to reorient your part the way you're going to machine it. In this case, we are going to bring it into our VMC like this. So I'm going to exit out of that face that I selected, and it brings us back to my initial selection for box point. All right, the next step is setting up our stock. So I'm going to choose the stock tab. We're going to go into our relative size. So a relative size simply means it's going to recognize the boundary of the part, and it gave us the minimum size stock around the part where we can plug in. So if the relative size I want to add, let's say a 1/4 inch around the part, and maybe I want to have, let's say, 100 thousandths on top, and maybe we'll go 3/8 into our jaw. And so we'll set up some parallels there, but I'm able to grow the stock around the model accordingly to the size and shape of the model. And I get the size of the stock down here in the dimensions. Now, perhaps you have a 6x5 by 1 inch part exactly as your stock. You can easily go in here and choose fixed size box, and now you can plug in exactly what your size of the stock is. And if I want to offset this to leave 100 thousandths on top, I can change the model position in Z to add, let's say, just 100 thousandths, and it shifts the stock around the model. So you do have some options in a different way that you could set up your stock. And if you ever work from a forged part or a cast part or near net shape, you can always choose from solid, and you can select out of the graphics view or the browser what that stock shape is exactly. All right, so excuse me. So I'm going to keep that that size. That's my stock size, and of course I can choose what my post-process number and name are going to be. And if I had multiple work offsets, I can choose them here as well. So I'm going to say OK. Now we're ready to start machining this part. We set up the stock to match, and we oriented it with our origin at the upper left corner. So now the first thing I want to do is face off that stock off the top, that 100 thousandths. So I'm going to go up and choose my 2D face toolpath. And this is what I love about our CAM is this workflow. It's always the same workflow for the toolpaths that you're working on. So working from left to right, choosing our tool, geometry, our heights, passes, and linking. Always the same, making it easy to learn and easy to use. So the first thing I'm going to do is I'm going to select a tool that makes sense for this part. So I'm going to face off the top. So I'm going to create a face mill. You could choose from our samples library, and you can find a face mill out of titanium or the material that you're cutting. So if I have a high carbon steel part, I can find a tool that is preset with speeds and feeds for that material. What I suggest is create a library that matches your machine. So if I'm working on a Haas VF2, I was able to create a library here. You can easily right click, new tool library, and and just name it exactly what your machine is. And then in that library, you can start to add a tool like we're going to do here. So I'm going to add the tool just to the part, but if I go up and add a mill tool, brings us into the new tool interface. And so I can start from left to right, put in the description, the vendor. We're working with Extrude or Harvey or Helical or Sandvik. You can plug in their particular ID and the product link. For our cutter, we're going to work with a face mill. And this is going to be a 5 insert carbide insert tool. We're going to make it 1 3/4 inch. I'm going to have a 20 thou corner radius and then a low profile 3/8 insert. My overall shaft diameter is going to be 1.5 inches, and the body width, or sorry, the body length will be 1/2 inch. So I have a very low profile, actually that's going to be 3/4, a low profile shell mill or face mill. And then I can choose a holder just to make sure that if we're going to check for any collisions or check to make sure it's going to match the machine, we can filter and you can find that we have a holder library, Marital holders, Uberchuck holders, Lindex holders. And in here, I'm going to choose a holder that makes sense. We'll get a Cat 40 ER32 type collet. Okay, and then I'm going to set up the feeds and the speeds that match the material that we're cutting. And I recommend using your tool vendor recommended speeds and speeds to start off with. So we'll do this at 50 inches per minute at 1,000 RPM. And then I'm going to plug in the tool number as well as the length offset. This will be tool number 1, and I can turn on my coolant the way I want it in the machine. And that's it. Now we have a tool set up that we're ready to face off the top of the part. I'm going to say OK. I can see the tool in the graphics view. The next step would be selecting geometry, but we don't have to because when we did our job setup, it recognizes where the boundary of the stock is. It knows where the top of the part is. And that's it. I just say OK, and we get a face toolpath. I'd like to see what that's going to look like. So I'm going to go up to face. While I have face highlighted, I'm going to go into simulate. And we can simulate right on our part exactly what the tool is going to do as it cuts through the material. All right, we can see in this case, we're going to rough, we're going to drop down 50 thou, and we're going to finish up with a 5 thou face on there. So that's our face toolpath. Quick and easy, we're able to get here and we can check that toolpath. Now, if I want to be able to change that step down, I can easily go in and edit that face toolpath, and in the passes tab, this is where we control our pass direction, our extension, step over, right? Our direction going both ways, and we can also change our multiple depths. So this is our multiple step down. If I want to do that, let's say at 25 thou per step down, and I want to finish up at, let's say, 4 thou, I can easily change that. I can even have a separate finish feed rate. And now we have multiple step downs at 25 thou and finishing up at 4 thou. So you can easily go in and change any of the aspects of your toolpath. Now, let's, I realize we're getting close to the top of our webinar of time. So I'm going to rough this out really quickly using a 3D adaptive. So a 3D adaptive clearing is our roughing strategy. This is our high efficiency machining. Notice we have the same exact workflow that we did before. So I'm going to select a tool. And in this case, I'm going to select one from my library from our Haas VF2. And I'm looking for a 1/4 inch rougher. So I'm going to filter on type flat. And here's our 1/4 inch roughing end mill. So I'm going to select that tool, opens that tool up, and we're going to use that to rough out as much as we can in this material. So I probably would get a bull nose, but in this case, we're going to use a flat to kind of go through as much as we can in the material that we have. So the next thing is selecting our geometry. In this case, I can select a boundary where I want to keep the tool, but otherwise, if I don't select the boundary, I just simply say OK, that tool is going to go everywhere it can to rough out and remove the chips as efficiently as possible. So here, if you look inside this pocket, we're going to helix down using a tapered helix. So at each pass, we leave room for the chips to get pulled out. As we start in the material, we keep a constant engagement. In other words, it's always the entire time as you're working through the material, especially when you get into corners where traditional tool paths are simply an offset tool path. When it gets into a corner like this, you'll often overload the tool and it could bury it and it can snap and break your tool. In this case, we always keep that same constant load in the material, and when it can't keep the load, it backs off, does a micro lift, rapids over, and it will feed back in at exactly the same load the entire time. So when you get into the corner, you don't have to worry about that overloading the tool in the corner or burial, where you don't have to slow your feed rates down. This will automatically give you the optimal load in those corners that's going to keep your tool a lot longer. Um, and so you can run higher feeds and speeds, get your parts off the machine a lot quicker, and you're going to save tool life. The same thing for the outside. It's going to work its way in almost like we're coring an apple. And especially when it gets into this open pocket here, it works its way in, always keeping that same constant engagement, the same chip size as it works into the corner where it removes the most efficient cut in the corner there. So let's take a look. So I'm going to highlight setup, right? We've already simulated the face. So I'm going to jump to the 2D adaptive or 3D adaptive. And then in this case, I'm going to kind of hide some of those toolpaths. I'm going to walk through what that toolpath looks like. So here it's going to helix down and then keep that same constant engagement as it works into the material there, right? Especially when it gets into the corners. And with a 3D toolpath, it's going to recognize those 3D features, right? So it's going to work its way on the outside, right? Keeping that same engagement, and it works its way up the walls, always keeping that same chip load. Right, so you get a more efficient roughing strategy, and now you can come back in here and finish, knowing that you only have that smaller material that you can now use a more fine tool, right? And then you don't have to do any pre-finish. You could just finish that up with a ball mill. So that's our roughing strategy, adaptive clearing. Real quick, we can do a couple more, but actually, before we do, I just want to rough this out just to get a good idea, because we're getting close to the top of our hour. So I want to be able to output that code. So I'm going to highlight setup one. We're just going to face it and rough it out on the machine. So I'm going to highlight this setup. We're going to go up and get a setup sheet. So I choose setup sheet. I could select a folder, and we get an HTML setup sheet that'll work on any computer when you open it up. So now we have our datum, our part that we're going to make, the tools that we're using, the number of tools, the maximum feed rate, maximum spindle speed, and the estimated cycle time it's going to take to run the whole program. How to set up each tool in the holders, right? And the estimated cycle time that each one of those tools are going to run, and then per operation. How to set up the tools with the length offset, corner radius, as well as the time it's going to take to be able to do that operation particularly. All right, so it's a good setup sheet right out of the box. Now let's get some code. So we're going to make this one our Haas VF2. So I'm going to go up to post process, and I'm going to choose my Haas next generation control. Okay, and so we have post processors that'll run. We work with Haas. It will run on most machines. I think we have about almost 150 posts that come with our software for free. These are not encrypted in any way. They're all open source JavaScript that you can always go in and make edits to your post as you need. And if you need help, you can always go online to our post library, where we have a manual that will walk you through how to edit your post, support that'll bring you to our forums, where we have expert users that'll be there to help you at any time. And then we have a link for adjustments. We have our partners and our channel of partners who will be able to help you dial in your post. Okay, so I'm going to output this code. So if I go to post process, I'm going to save, I'm going to overwrite that 1001 program I did earlier. And this will bring up our code. And now we can send this program directly to, oh, this is the one right here. And we can send this to the Haas to be able to cut out this part and rough it out. One of the coolest things about having an integrated CAD CAM interface is that if, and at any time, the design has to change, right? So if I go in to change this design, we're going to go in and edit, and I'm going to make some changes, and we're going to make this, instead of 2 inches, it's going to be a very skinny profile at 1 3/4, and then this is going to be 3.5 inches. So we're making some pretty big changes to our design there. And this overall width, instead of being 50 or 1/2 inch, it's going to be 3/4 of an inch. And the same thing over here. So I'm making some pretty big changes to our design. And if I go back into our manufacturer, notice our toolpath still want to cut the old shape. If I right click, generate, and now it regenerates and recalculates exactly to the new model dimensions. And now, and within seconds, we're able to make a design change. And if I go into setup, post-process, we can now post out the code for that new design that we have. And that's the power of integrated CAD and CAM in one place in one interface. All right, so I think any follow-up questions? I know we're at the top of our hour. I don't know if we have any questions we can answer real quick. But Charlie?
Yeah, so currently there's no additional questions, but if you guys have some questions, please feel free to use the Q&A section on the video conference software, and we will reach out to you guys, and you'll have contact information for us. So if you've got further questions, please reach out to us. So we really appreciate you guys taking the time to look into Fusion 360, and that's about it. Wayne, anything else before we go?
Yeah, if you guys are new and working with Fusion 360, up here in the question mark is a great place to start with learning Fusion. There's a learning panel that will pop up and take you through each step-by-step of the, and give you help as you're working through design and manufacturing. And learning and help, the start here is a great link, brings you to our main page where we have classroom type training that you can walk through step-by-step on getting started with sketching, with modeling, with your overall design, with assemblies, and working with each of the interfaces, as well as the working with the workspaces, and all the way through to CAM. So this is a great place to start. And again, I found it up in this corner with the question mark. And also you can get into our community forum as well, some help. So these are great resources available to you with your subscription that you can get up to speed quickly in Fusion 360. But with that, that's pretty much all we want to show this week. And yeah, hopefully it's been helpful for you guys. And as Charlie had mentioned, if you guys have any additional questions, please feel free to reach out to us directly. Awesome. Thanks, guys. Have a great week.